Overclocking is the process of running a computer component faster than its official factory speed. It is most commonly done with a CPU or GPU to increase performance. Every processor has a rated clock speed that determines how quickly it performs calculations. By adjusting settings in the system firmware or software tools, users can increase this clock speed. The goal is to get more performance from existing hardware. Overclocking is often used by gamers, enthusiasts, and performance-focused users. Computer processors operate using a clock signal that controls how quickly operations occur. This clock speed is measured in gigahertz, or billions of cycles per second. Overclocking works by increasing this clock frequency beyond the manufacturer's default setting. When the clock speed rises, the processor can perform more operations in the same amount of time. This can improve performance in tasks like gaming, video rendering, and simulations. However, increasing the clock speed also increases heat and power consumption. Because overclocking increases the speed of a processor, it also generates more heat and draws more electrical power. If the hardware becomes too hot, it may become unstable or shut down to protect itself. For this reason, effective cooling systems are important when overclocking a PC. Many users install larger air coolers or liquid cooling systems to manage the extra heat. Stability testing is also necessary to ensure the system can handle the higher speed. Without proper cooling and testing, overclocking can cause crashes or reduce hardware lifespan. Overclocking is usually performed through system firmware such as the BIOS or through specialized tuning software. Users adjust settings like the CPU multiplier, base clock, and sometimes voltage to achieve higher speeds. Each adjustment must be tested to ensure the computer remains stable during heavy workloads. Performance improvements vary depending on the hardware and cooling setup. Some systems may only gain a small increase, while others achieve significant boosts. Careful tuning allows enthusiasts to maximize performance safely. Overclocking allows users to extract additional performance from their computer hardware without upgrading components. By carefully increasing clock speeds and managing cooling, systems can perform tasks faster than their factory configuration. However, overclocking also carries risks if settings are pushed too far. Instability, overheating, and hardware stress can occur if limits are exceeded. For this reason, most users increase speeds gradually and test stability after each change. When done carefully, overclocking can provide noticeable performance gains.